Here are solutions to homework set number 6 for ECE 376. The first problem is generate a ferrous six-sided die using your pick chip. So here's kind of the heart of the main code. That's not the whole program. You need the setup to initialize the LCD, initialize the serial port, stuff like that. But here's the heart of it. Is that a fair die? Well, if you can look at the code, it does look like a fair die. I'm not favoring any number versus another. Suppose I don't have access to the code. For example, it might be proprietary. The manufacturer won't release it to you. Can I still tell whether the die is fair or not? So for example, here's the code running on the pickboard. Every time I hit RB0, it generates a new number between 1 and 6. It also ships the data out on the serial port right here. So if you look on your terminal emulator, these numbers appear as well. So I can sit there and do a whole bunch of numbers, collect them, and throw them in MATLAB, count how many times you get a 1, 2, 3, 4, 5, and 6, and so on. Well, that's the first step of using a chi-square test. To find out whether it's a fair die, I'm going to collect a whole bunch of data. So here I rolled the dice 60 times, and here's how many times I got a 1, 2, 3, 4, 5, and 6. I then calculate the chi-squared value, setting up a chi-squared table. What this does is I take the expected number of 1s through 6s. If it's a fair die, they should all be the same. This is the actual number of 1s, 2s, 3s, and so on. The chi-squared score is the difference squared, so it's n minus np. The difference squared divided by np. So 1 squared divided by 10 is 0.1, 3 squared over 10, 0.9, 1 squared over 10, 3 squared, and so on. Take all these, add them all up. I get the chi-squared value. To convert that to a probability, I use a chi-squared table. I've got 6 bins, meaning 5 degrees of freedom. My chi-squared value is 4. Convert that to a probability. Another way is to use StatTrack. If we go to stattrack.com, again, that is stattrek.com. Just a great website for statistics. One of them is a chi-squared table. I input 5 degrees of freedom. Chi-squared critical value is 4. Calculate. It tells me the probability is 45%. So that means there's a 45% chance that this is a loaded die, or this is not a fair die, rejecting the null hypothesis. Basically, that's no conclusion. With the chi-squared, if the number is too small, that indicates that I rigged the data. If it's too large, it means the data is not your assumed distribution, a fair die in this case. In the middle is no conclusion, and that's really typical. So it looks like this code is generating a fair die, at least after 60 rolls. Now, change the program. I can now tell that this is a loaded die because 15% of the time I'm always rolling a 6. The rest of the time it's fair. If I try that, I can sit there and take the code and roll it. So I got a 3, 1, 6, 6, 5, 6. Am I getting too many 6s? Well, again, that's a chi-square test. To determine whether this is a fair die or not, repeat. Collect a whole bunch of data, and I roll the dice 60 times, and here's how many 1s, 2s, and so on I got. Again, notice I'm getting too many 6s. Throw it in a chi-square table. So I should be getting 10 of each number. This is how many I got. The difference squared, so 11 squared divided by 10 is 12.1. Add them all up, I get 15.8. To convert that to a probability, throw that in a chi-squared table. 5 degrees of freedom, meaning 6 bins. Chi-squared critical value is 15.8. Probability is 0.992. So I can be 99.2% certain that this is a loaded die. What that kind of tells you is 15% loading is a little bit heavy if I'm going to roll the dice 60 times. 3 or 4 rolls I can't really tell. 60 rolls, apparently I can see that. You can actually calculate how loaded you can make the dice and get away with it. And right around 10% loading, they only 5% chance of detecting it with only 60 rolls. If I roll the dice often enough, I can detect any amount of loading, but it could take a lot of rolls. With a limited number of rolls, like 60 rolls, it's really hard to spot 10% loading. 15% is getting a little bit heavy. Problem 3 is determine whether or not you're psychic. So here's the idea. I'm going to predict what number is going to come up. This is generating a random 4-sided die, same as a 6-sided die, just 4-sided. And I'm going to predict, is it going to be a 1, a 0, 1, 2, or 3? I think it's going to be a 3. And I was wrong. I think it's going to be a 1. I was right. A 2. Wrong. 0. Wrong. 0. Wrong. 2. 3. 2. 1. 1. 3. 2. 1. This is kind of a way to collect data automatically. You can sit there and guess what number is going to come up and see, are you correct more than you should be? Are you psychic? Well, the first step is write a program that keeps track, generates a random number, keeps track of which number you bet on, and sees if you're right. So this is kind of the same idea as before. Instead of doing while RB0, not RB0, I'm going to say while no button's being pushed. So right now it's waiting for a button. As soon as I push a button, it sits there and counts really, really fast, mod 4, and records which button did I push. So if I hold down like the 2, it's counting really, really fast. When I release, it generated a random number, checked to see was it equal to 2. If it was, I was right, otherwise I was wrong. Display how many times I'm right and wrong. And then check, am I psychic? So again, this is a chi-square test. Roll the dice a whole bunch of times, count how many times I'm right, how many times I'm wrong. In this case, I was right 15 times, wrong 49 times. Set up a chi-square table. I guessed, what was that, 64 times. 1/4 of the time I should be right, 3/4 I should be wrong. How many times I actually was right and wrong? Take the difference squared, divide by expected value, add them all up. The chi-squared critical value is 0.08. Well, to convert that to a probability, go to StatTrack. I've got 1 degree freedom, only 2 bins. My chi-squared critical value is 0.08. That corresponds to a probability of 22%. And again, if the number is really, really small, it looks like I fudged the data. If it's really, really big, I'm not just guessing. You'll be afraid. I'm just 22%, so it looks like I'm pretty much just guessing. So sadness, appears I'm not psychic. But anyway, that is homework set number 6 for 376, chi-square test.